Hey everyone, welcome back to the channel. Today we are tackling a popular interview question, finding the minimum element in a sorted and rotated array. This is a great question to practice binary search, and the solution is optimized to run in big O of log n time. So let's break down the problem and solve it step by step. Here is the problem. You are given a sorted array that has been rotated an unknown number of times. For example, the array 0, 1, 2, 4, 5, 6, 7 might be rotated to 4, 5, 6, 7, 0, 1, 2. So it is rotated to 4 times because you would see the 0 was first at the first position, and in the second time it's in the fifth position. So it's been moved to the right 4 times. Now our task is to find the minimum element in this array. We need to ensure that our solution runs is big of log n time. So for example, if the array is 3, 4, 5, 1, 2, of course the minimum would be 1. Some important constraints are that the nums element number would be between 1 to 5000, and all elements in nums are have to be unique, and nums is sorted in ascending order before being rotated. Since the array is sorted and then rotated, a binary search approach is perfect because it allows us to find the minimum element in big O of log n time. So here is the approach. We first initialize two pointers, left and right, pointing to the start and end of the array, respectively. Use the binary search loop while left is less than right, and then calculate the middle index. Then in the third step, we have to compare the middle element with the right element. So if nums of mid greater than nums of right, it means the minimum is in the right half of the array. Else, if nums of mid less than is equals to nums of right, the minimum is in the left half, including the mid. After the loops ends, left will be pointing to the smallest element in the array, and we will be returning that value of left. And now let's solve the code in the LeetCode IDE, and I'll be giving you this Notion link and my GitHub link in the description, so from there you can have your code. So as we discussed before, we first initialize two pointers, as left would be 0 and right should be nums.length minus 1, which indicates the last element of the array, minus 1. Okay, now we have to perform our binary search. So in binary search algorithm, it's pretty simple, and it helps us to find the minimum element in big O of log n time because it divides the array into halves. So while left is less than right, we'll be calculating the mid element, which is left plus right minus left by 2, which is mid is equals to left plus right minus left by 2. Okay, now if the nums of mid is happens to be greater than nums of right, then the left element becomes mid plus 1 because it's in the right half of the array. Okay, and elsewhere otherwise our right element is mid, mean our element is in the left half of the array. Okay, now we'll simply return the nums of left because that's where our minimum element will be. That's it. Now let's run the program and see if it's clear all the test cases. So yeah, so for the first case, 3, 4, 5, 1, 2, 1 is the minimum one. Wait a minute. Okay, and for case 2, of course 0 would be the minimum value, and for third one 11 would be the minimum value. Now let's submit this and see its accuracy. And okay, So we have solved our 8th question of our LeetCode array, and we'll be solving all important LeetCode arrays in future. So thanks for watching. If this video was helpful, please like and subscribe.